Hello, I'm Douglas Miranda, and in this video I will teach you how to apply ModelBuilder to connect your hydraulic model with Geodatabase in WaterGEMS for ArcMap. In this exercise we will see how to connect your hydraulic model to ArcGIS Geodatabase using ModelBuilder. We are going to use the WaterGEMS integrated with ArcMap's interface. So if you'd like to see which versions of ArcMap are integrated with your version of WaterGEMS, please see the README file. The README file can be opened within the installation folder, like on C drive under Program Files x86, Bentley, WaterGEMS. It's a PDF file. So before opening WaterGEMS for ArcMap, let's first check the geodatabase that we are about to integrate with. So to do this, let's use our catalog. Opening Arc catalog, go to the workshops folder that you imported within your machine. So the folder is the WaterGIS GIS. Within this folder we have another folder called ModelBuilder. In this folder we have a geodatabase called ModelBuilder Starter GIS. So in this geodatabase we have a network that consists in 3 geodatabase feature classes: accessories, pipes, and tanks. Expanding network, you can, for example, select the accessories feature class and click on the Preview tab. The Preview tab shows to you how this feature class looks like geographically, or you can switch to the table preview mode, where you can see all the information. So for accessories, we have information regarding elements elevation and elements labeling. The same we can do with the other feature classes like pipes. This is the table preview and the geography preview. And for tanks, we have 2 elements, 2 tanks with label information, diameter, control elevation, and ground elevation. So this is good to understand how your information looks like and which information is important to your hydraulic model. Now we can go to the ArcMap interface integrated with WaterGEMS. So you can select the icon, the gray icon, WaterGEMS for ArcMap. Starting this, it will bring to you the ArcGIS interface. Let's open a new file using the blank map as template. So once having ArcMap interface started, you can load WaterGEMS toolbars. Remembering that WaterGEMS is not an add-on, it's an integrated platform, so you can go directly on the Customize menu and access under Toolbars the WaterGEMS toolbars. So the main toolbars, it's the Layout toolbar, the Tools toolbar, and the View toolbar. After adding these toolbars, you can dock it to your top bar. So to begin hydraulic modeling, let's create a new hydraulic model that will be connected to this ArcMap MXD file. So clicking on the Bentley WaterGEMS menu. This Bentley WaterGEMS menu is related to the WaterGEMS layout toolbar. Let's select File, Add New Hydraulic Model. So select your preference folder. I will select the folder I extracted on my machine. Within WaterGEMS, I will select the ModelBuilder folder, and I will call this model as ModelBuilder Geodatabase Workshop. It will bring to us a dialog box to create the geodatabase that will connect the MXD file to the feature classes. The feature classes related to the hydraulic model, such as pipe, junctions, tanks, valves, and etc. So let's create the geodatabase, clicking on the dialog window button, and let's call this ModelBuilder Geodatabase Workshop. And let's use feet as coordinates unit. Clicking OK. It will generate the geodatabase and all the feature classes under the table of contents, as you can see at the left panel. Let's keep this chain tracking tool for now. Let's click in No. And after loading the new hydraulic model, we can now start the connection using ModelBuilder tool. ModelBuilder tool is available under the Bentley WaterGEMS menu, under Tools, ModelBuilder. If you added the WaterGEMS tools toolbar, you can see the ModelBuilder's icon. So in this dialog box, you can face an empty window, or you can see some other ModelBuilder connections. So it depends of your machine situation. So in my case, I have two previous connections made by this same exercise I did in other opportunities. So for us, let's create a brand new one. In the next window, we will pick on the select data source type the ArcGIS Geodatabase features option, and let's connect it using the browse button. So let's now connect to the WaterGIS folder, ModelBuilder. In this file, we have an existing geodatabase called ModelBuilder Starter GIS. It's the same one we saw on the Arc catalog. So with double click, we see the network option, and with a double click again, we can see the three feature classes we saw previously. So selecting the tree, clicking on open. Now we are about to connect these three feature classes. You can use the show preview button to see that same information we saw on their catalog tool. Clicking next, we will define the coordinate unit of the data source, its feet. Below we have an option that is currently enabled to create a node if none found at the pipe endpoint. It's an option important to avoid pipe with no element at the endpoint. If it happens, the pipe will not be imported. In this first moment, let's keep this option disabled just to see what happens if you don't have an element at the pipe endpoint. And the second option is to use a minimal tolerance. This is also another important option that will be using initially disabled to understand the consequences. Clicking next, you can go directly clicking twice to go to this option called specify additional options. Let's keep the current scenario option because we have nothing in the new hydraulic model, so there is no problem to import all the information using the current scenario. And let's keep also the options to map elements by a key field. It's important to map elements by attribute with element's name instead of using a spatial join tolerance. So the second option is when you don't have like a label as a key field, remembering that the label field in your source file must be unique. So clicking next. Let's now do the field mappings for each feature class. Starting with the accessories. The accessories feature class, it's related to junctions. So on table type, let's keep the junction option. For the key fields, let's select the best attribute to represent elements identification. So let's use the label option. And the X and Y fields will be automatically extracted from the feature class information. Below we have the opportunity to connect all the relevant attributes to the relevant WaterGEMS property. In this case we have the elevation. The elevation feature class attribute can be connected to the WaterGEMS elevation attribute. Selecting elevation field. Now we have these two fields mapped, and this is an attribute that contains information in feet. So this is important to keep attention in the unit option. Jumping to the pipes feature class, you will see that automatically the table type is defined to pipe. It happened because ModelBuilder understands the feature class type. It will see if it's a point, polyline, or a polygon. Under key fields, select label. On the starting point, start and stop points, you can select if present an attribute for pipe that has the name of the point element at the endpoint. So in this case, we will use none. So let's keep the option none. And now let's map the fields for, let's start with diameter. So the WaterGEMS property, it's also named diameter, and informations in inches. Let's now go to the last feature class, tanks. The table type, selecting tank, key fields, label, X and Y will be automatically. And now let's map first the diameter. The tank diameter will be connected to the tank's diameter field, and it's in feet. The ground elevation, it's another important information. Let's connect it to the elevation base property. So now let's click next. You can skip the snapshot configuration. And finally, we can finish our ModelBuilder connection. Clicking yes to this operation information regarding that's undoable process. Now we can see ModelBuilder summary. It's a summary that has some messages. These messages are important because they are in red. So if you have messages in red, it means that something went wrong. So selecting the Messages tab, you can see that pipes could not find their start and stop nodes. So to resolve this issue, we need to go back to ModelBuilder and use that two options we cleared in the beginning, to use a tolerance and use the option to connect, to create a junction automatically if none found at the pipe endpoint. So let's close the summary, and with double click again in the ModelBuilder Starter GIS, we can run again all the process. So clicking next, let's now select the create nodes if none found at the pipe endpoint, and let's check the second box to add a tolerance. So this tolerance will be 0.1 feet. And now we can go directly to the end. On the last step, pay attention that we need to choose the yes option under you'd like to build a model now. So clicking finish, it will run again the connection process. Now we have yellow messages. So in the summary, we have 6057 pipes created and 8 missing nodes created at pipe endpoints. This yellow message is regarding these missing nodes. So it's just details about which nodes were created and which pipes were found with no endpoint element. Closing the summary and the ModelBuilder's dialog box, clicking yes to synchronize your drawing. You can use the ArcMap's full screen extent button, or under the table of contents For example, you can select the pipe or junction feature class. With right click, you can select the zoom to layer option. So this is the elements connected and imported to your hydraulic model. Let's now review all the information created with ModelBuilder. So one way to check the information is using flex tables. So selecting the Bentley WaterGEMS menu, you can go to View, Flex Tables. It will open the Flex Tables Manager. Under the Flex Tables Manager, we have 4 groups of tables. The Geotables, it's tables that will select the columns that will be seen in the table attributes within ArcMap. Or you can select the predefined. The predefined group, it's some example of tables that you can use initially for your analysis. And the other 2, hydraulic model and shared, can be used to create your own flex table, defining which columns you need to see. The shared is where you can create your tables, and it will be saved in your machine, and it will be available for all hydraulic models you open in your machine. If you choose the hydraulic model first group, the flex table created here will be seen just in this hydraulic model. So let's use the predefined one. So starting with the junction table, we can see, for example, the elevation information. There's some elements with no elevation. Okay, and others we have information elevation. Jumping to the pipe table, we have diameters. Diameter was the information that we connected for pipes. And finally, for tank, we have label and elevation base and its diameter. Let's now complete the missing information to run our hydraulic model. We can do this using not necessarily the WaterGEMS for ArcMap interface. We can use the standalone interface. So now let's see how we can jump to the standalone interface, and if needed we can of course jump back to the ArcMap interface. So let's first save our file. So clicking here on the ArcMap interface, clicking in save. Let's save this file as ModelBuilder hydraulic model. This will save the MXD file. And closing its interface, you have an option to save the hydraulic model too. So you can click and save. And now opening WaterGEMS standalone using the blue icon. We can open this hydraulic model. it's the same information, so you can edit using standalone, and with this you can leave the ArcMaps license for another colleague. Let's start with the tanks information. So we can use again the flex table, accessing the tank table. Let's fill the tank's initial elevation, minimum and maximum elevation. So all this information, it's available on the page 25 of the workshop's manual. So minimum it's 1460 for both, initial 1475 for both as well, and 14.8 for both. Next, we will define the system demand. In this exercise, it's demand equals to 2 gallons per minute for all junctions. To do this, we can access the demand center under the Home tab, demand control center, and here we can click on the new button to initialize demand for all elements. So all elements will receive a 2 gallons per minute demand. So let's use the global edit function, and easily we can set 2 gallons per minute. Okay, so let's see what happened if we run our model to see if you have any user notification messages. Apparently, we don't have any major problem. Let's see our pressure at junctions. Again, we can use the junction table. On the junction table, remember we have some elements with no elevation, so as consequence we have higher pressures. If we sort this pressure column in ascending order, we can see we have low pressure problems. So to do this, right click on the pressure header and select sort ascending. So there is a node with 7 psi of pressure. It's the A311. To go to this element, we can do with a right click on the first gray column and select the zoom to element. So closing, we can see that the 311 is close to the tank hillside. So this is why we have low pressure. Now let's solve the elevation problem we saw on the junction table. So let's now sort the elevation column in the ascending order. And now let's see the elevations that we need to put in these elements. Just a quick note, you see that we have elements with J as a prefix. It's the default option that WaterGEMS use for elements, for new elements. And this is the 8 elements that ModelBuilder created using the pipe connection tolerance. So on the page 30, we have the elevations to be entered for these elements. So now we are good to recompute. So computing again, I am going to compute without closing flex table just to see the results automatically updating in the table. So now we have better pressures in these 8 elements. Another tool that we will see in this exercise is the Network Navigator, a very important tool to check if you have any topology issues. For example, if you have any junction that is really close to a pipe, being a pipe split candidate. So let's see how Network Navigator works in this case. So accessing menu, view menu, there is the Network Navigator close by the end of the top bar, close to the contours button. So in the Network Navigator, click on this select button, and we have some options under the network review group. One of them is the pipe split candidates. So let's see the junctions that is close with a tolerance of 20 feet to a pipe. So clicking OK. There are 4 elements that is closer than 20 feet. So let's go in this first one, the A663 element. So if you double click, you can see that this element is very close to this pipe 3134. The A925, it's here. So it's situations where you may need to go back to the original as-built drawings to decide if connection really exists in the field. If there is an error, you need to decide if you want to correct it only in the model or in the GIS, and then re-import to the model. Another element is the 924 and the 985. This is one of the most common cases. It's an element that is floating, and apparently that means it's correctly that the pipe 2200 needs to be broken. So this is a case to go to the as-built drawing. Let's go to another Network Navigator query. It's the nodes in close proximity. So let's go in the select, network review, nodes in close proximity. Let's use now a 30 feet tolerance, and we have a single element, the 774. It's another situation. So it's an element that we have a node very close to the node 722. So if 2 nodes are in close proximity, only one of the nodes is listed in the Network Navigator. Without additional information, it's difficult to determine if these nodes are correctly.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.